Now we'll find equation of a chord joining 2 points on the parabola. So equation of a chord. Of a chord. And then we will find condition for focal chord. If this chord is passing through focus, what must be the condition for focal chord? And then we can find length of the focal chord and relationship between focal radii and lattice rectum. So 3-4 things we will do from this concept. So equation of focal chord. So if any parabola is there, 2 points are there on the parabola. Let us consider point A as a t1 square comma 2a t1 and point B as a t2 square comma 2a t2. This point simply, A point I can say point t1 and B point I can say simply point t2. This you must understand that when I say point t1, that means I am talking about the point on the parabola whose parameter is t1. So a t1 square for standard parabola I am talking about y square is equal to 4ax. And point t2 means this. So these are 2 points. This is my standard parabola and these are 2 points anywhere on this parabola. Anywhere. A, B. This is point t1 simply. This is point t2. Now I have to find equation of this chord. So very simple method, 2-point form, 2 points are given. I can find equation of this chord joining 2 points. So y minus y1, 2a, t1 is equal to 2a, t2 minus 2a, t1 upon y2 minus y1 upon x2 minus x1. x2 means a t2 square minus a t1 square into x minus a t1 square. So this you can simplify, a will cancel. So this you can write y minus 2a t1 is equal to, a will cancel, 2 upon t2 minus t1 into t2 plus t1. 2 is outside t2 minus t1. So t2 minus t1 will cancel. We will left here t2 plus t1 into x minus a t1 square. This is the equation of the chord of the parabola. You can simplify also, multiply. So that will give equation of the chord of the parabola joining any 2 points t1 and t2. The important point here is if this is passing through focus. Suppose I say this is passing through focus as a comma 0, then it will be called focal chord. We have already given the definition of focal chord. What is focal chord? Focal chord, any chord passing through focus is called focal chord. Any chord passing through focus is called focal chord. So this is a focal chord. For example, a particular case I am discussing, what must be the condition if it is a focal chord? Then if it is a focal chord, this implies that the chord must pass through focus. Must pass through focus. What is focus? As a comma 0. This is the focus here. So that means a comma 0 must satisfy this. So we will put y is equal to 0. So 0 minus 2a t1 into t2 plus t1 is equal to 2 into x is a minus a t1 square. Simplify this. 2 will cancel out. A will also cancel out. So minus t1 t2 minus t1 square is equal to 1 minus t1 square. This I have taken outside a and a is cancelling here. This a will cancel this a and this a. So it is 1 minus t1 square is left here. So t1 square will cancel out t1 square. So this gives me that t1 t2 is equal to minus 1. This is the condition. If t1 t2 is equal to minus 1, this will give me equation of the focal chord or ends of the focal chord. That means if I know one end, I can calculate other end by replacing T2. I will get T2 is equal to minus 1 upon T1. So if A is a T1 square comma 2A T1, B, instead of writing in that form A T2 square comma 2A T2, I can replace T2 with minus 1 upon T1. So this will be A upon T1 square comma minus 2A upon T1. This will give me the equation of chord. From here, A and B are two ends of the focal chord. So I can calculate this as focal chord. Next thing is, question arises, what is the length? One more point I can calculate, that is length of focal chord. Length of focal chord. That means this is nothing but AB. So for this, one concept we have already done, we can use that. That means AS will be equal to AM. A is a point on the parabola. Distance of this point from the focus must be same as distance from the directrix. Similarly, B is a point. So this must be equal to BN. We have done that. Focal distance of a point. Focal distance of A will be how much? A plus x1. X1 is the coordinate of that. That's this point we have already done. Focal distance of a point. This distance AS, focal distance, this will be equal to AM. And this is how much? This is 0, this is minus A. So this distance is A. And this distance is x coordinate. Suppose this is x1, y1. Then this distance is x1. From x1 I am going, then y1. So total distance is AX1. A plus x1. That means SA distance is equal to A plus x1 coordinate is A T1 square, and SB is equal to A plus A T2 square. And we have already calculated A T2 square is equal to A plus A upon T1 square. So total distance SA plus SB, that means AB. I will add both. So AB is equal to, add both, A T1 square. So A I am taking outside. This will be T1 square plus A 2A. So 2 plus 1 upon T1 square. And this we can write as A T1 plus 1 upon T1 whole square. When I am adding both, A plus A 2A, A is outside, so this is 2A. A is common from here, so what is left? A T1 square plus 1 upon T1 square plus 2, and this is T plus 1 upon T whole square. So this gives me length of focal chord. So here 2 points are very important in this. First is we have calculated equation of the chord. After calculating equation of the chord, I want to know the condition when this chord becomes focal chord. So if it is a focal chord, it has to pass through focus. Any chord which passes through focus is called focal chord. So this must satisfy the coordinates of the focus. Focus is A comma 0. So this chord is passing through A comma 0. So I am replacing here y with 0, x with A. Y with 0, x with A. So I got this equation 0 minus 2A T1 is equal to 2 upon T1 plus T2. So I have multiplied this. T1 plus T2 is equal to 2 into x is A minus A T1 square. A is cancelling here. 2 is cancelling. So minus T1. T2 plus T1 multiply. So minus T1 T2 minus T1 into T1. T1 square is equal to 1 minus T1 square. T1 square will cancel. So T1 T2 is equal to minus 1. So from here I got T2 is equal to minus 1 upon T1. That means if I know coordinates of one point of focal chord, I can calculate coordinate of other end of the focal chord. So if A is A T1 square, comma 2A T1, B will be replace T2. 1 upon T1 is minus 1 upon T1. So it is minus 1 upon t1 square. So minus square is plus. So a upon t square, t1 square, comma 2 minus 2 upon t1. And if I want to calculate length of focal chord, AB, so focal distance, this we have already done. Focal distance of any point from focus is a plus x coordinate of the point. So x coordinate of this point is a t1 square, this. And x coordinate of this point is a t2 square. So a plus a t1 square, a plus a t2 square. If I add both, I will get this total length. So AB is equal to a plus a t1 square. Instead of this, I am writing a upon t1 square. A is outside, so t1 square plus 1 upon t1 square plus 2. So this gives me a t plus 1 upon t whole square. This is the equation of the focal chord.